So on the screen here, we have the different SNAP programs from our tutorials, and these will come in handy. I've also included a summary of the high-level algorithm in this sticky note over here, so we can refer to it if we ever forget a step. So here we have the program that creates scores list and makes it full with random numbers, and this is the exact same code we used to find the smallest score from the tutorial. So let's recall that the first stage of the algorithm told us that we have to repeat these 3 steps, so finding our minimum, inserting it into our results list, and removing from scores list as many times as there are scores in the original list. That means that we need to have a repeat block. So let's grab one. We're going to go to our control palette, and we're going to drag a repeat block into our scripting area. So what actually goes inside this repeat block? Well, the whole algorithm, of course. So the first step is finding the minimum. We have this whole repeat block ready, so let's just go ahead and drop it inside. Before that though, we're just going to get rid of this say smallest score block because we actually don't want that inside of our loop. So what we're going to do is we're going to drag this whole program into our loop, like so. Now notice that we actually have a repeat loop, this inner one here, nested inside of an outer loop. That's because we need to find the smallest score, which requires this repeat block here, as many times as there are scores in the original list. So we need to repeat this outer loop for however long our list actually is. Okay, what else? We have to insert the smallest score into our results list, and we have to delete that score from scores list. But before we can even insert it into results list, we actually have to make that list. So let's go create a new variable. We're going to call it results. And just like before, we're going to drag in a set block here that sets results to an empty list, like so. Okay? So now we can drag blocks that insert into results list and that delete from scores list. So I'm going to leave these here for now. We'll sort of drag them in and fill them in a bit. But remember, to delete an item from a list, we have to tell Snap the position of that item. We can't tell it its value. We have to give it its position. We want to delete the smallest score we found here. But right now, this whole repeat block doesn't deal with positions. It deals with the score itself. So what we need to do is we actually need to update this code a little bit to make it talk about the position of the smallest score instead of the score itself. And that's a pretty easy fix. The first thing we're going to do is we're going to create another new variable called position of smallest. Now what we're going to use this variable for is we're going to use it to actually keep track of the position of the smallest score. So let's start changing this repeat block now. Instead of setting smallest score to an item, what we actually want to do is we want to set position of smallest to a position, right? But what position exactly? Well, let's look at our condition. Right now it says if the item at position of scores list is less than smallest score. So this is a value and this is a value, but we don't want that. We want this to be a value and we want this to reflect a position. So we're actually going to change this to say if item at position of scores list is less than the item at position of smallest of scores list, like so. So now we're checking to see if an item at some position is less than an item at some other position. And once we find that, we can see that we can set position of smallest instead of to the item at position. We can get rid of that and we can just set position of smallest to position. So if there isn't in fact a score that is less than the score at position of smallest, the position of smallest will now become position. So whatever this number is, it reflects the position of the smallest score. Okay, now that was the first fix. We needed to fix our condition. The second fix was we needed to set position of smallest to position. Now there is one more thing. We need to make sure that instead of talking about smallest score up here, we are actually talking about position of smallest. And instead of 9,999, we're going to set that position to 1. This is because we want the inner loop here to start checking positions at 1 for both the position we're comparing against and position of smallest. And remember, if there is a score that's smaller, position of smallest will just update itself. Okay, so now we've updated this code to, instead of talking about values, talking about positions. We have this step done, check. We have this step mostly done, check, because we have it nested in an outer loop. So now we just need to complete these two steps, adding an element to the end of results list and deleting it from scores list. So let's grab this insert and delete block. What do we need to insert and delete? Well, we need to insert the item at the position of smallest of scores list, right? Because that's going to be our smallest score. And we want to insert it at 1 of results list, right? And then we want to actually delete position of smallest of scores list. So these two blocks insert the item at the position of smallest, which is hopefully our smallest score, into results list, and then we delete the value at position of smallest from scores list. So that's step 2 and step 3. Now remember, we need these steps to repeat for as many times as we have numbers in our original list, which means they need to be dragged into our loop. But just be careful of one thing. We actually don't want to put these in the inner loop here. So remember, this inner loop, the repeat length of scores list loop, that's just finding the position of the smallest score. When we want to insert and delete things, we actually want that to be in the outer loop, not the inner loop. Now the last thing we're going to do is we're just going to grab a say block, we're going to put it outside of the loop, and we're going to ask it to say results. That's just so that we can check to make sure that our list is actually sorted the way it should be sorted. So before testing our code to see if it worked, let's go over it one more time. So we're going to set results list to an empty list. We're going to repeat 10 times, in this case because 10 is the length of our list. We're going to set position of smallest and position to 1. And then our inner loop, which checks for our smallest position, is going to go for the length of scores list, right? Because we only want it to repeat for however many scores there are in the list. What it's going to do is it's going to check if the item at position of scores list is less than the item at the smallest position of scores list. And if it is, we're going to update position of smallest so that position and position of smallest always reflect the smallest score. And if this condition isn't held true, we're going to change position by 1 so that we keep checking new positions against position of smallest. Now, once we find what position of smallest is and this loop finishes, we're going to insert the item at that position into results list. We're going to delete the item at that position from scores list. So we're doing step 2 and step 3. And then this last little say block here is just to check if we did our job right. So let's grab one more say block. And let's put it up here and ask it to say scores list. So now if we click this one, we get our list, 95, 67, etc., etc. Oh, there we go. So when I click this whole program, we should see a sorted list. So if we look into this one, 5 is the smallest score, then 14, then 40, then 42, etc., etc. Oh, sorry, I missed a 30. 5, then 14, then 30, then 40, etc., etc. You get the idea. So if we hit the program, there we go, 95, 94, 90, etc., etc., with 5 all the way at the bottom. Now, this is sorting it from greatest to least. If you wanted to sort it from least to greatest, there's actually quite a simple fix to do that. So remember, here we're inserting item at position of smallest at 1 of results. If we instead change this to say last of results, and we run the program again, so now we have a new list with 10 as the smallest score, and then 31, 39, etc. And we click on our program again, now you'll see that it's from least to greatest. And all of that is how to implement the sorting algorithm we talked about in Snap.